And if I told you once, I ain't gonna tell you twice. Salute all my real ones. Yeah. So listen, champ. We have researchers prove that the universe has an end. How can something that is supposed to be infinite have an end? This and more on your 6 o'clock news. We gonna get straight to the video. Like button, subscribe button, notification bell, press those. Let's go!
As far as we can see across the cosmos, we don't see anything that may look like the edge of the universe. The only limit we know of our universe is how much of it we can observe. For example, scientists believe that the universe is not infinitely old. It's theorized to have begun with the Big Bang 13.8 billion years ago, which is why we can't see the entire universe, as light has only had 13.8 billion years to travel, thus making up the entirety of the observable universe. But what is there outside this visible bubble? Countless galaxies as far as there can be? Or does the universe have an actual end? Welcome to Factnominal, and today let's find out if the universe is infinite. About 100 years ago, two genius scientists, Harlow Shapley and Herbert Curtis, met in the great auditorium of the Smithsonian Institution's Natural History Museum in Washington, D.C., to debate over a simple question: how big is the universe? Mind you, this discussion happened a little earlier than Edwin Hubble discovered the nature of galaxies. Curtis argued that the cosmos may consist of many separate island universes, claiming that the spiral nebulae were distant systems of stars outside our Milky Way. Shapley believed that the so-called spiral nebulae were merely gas clouds within the Milky Way. Shapley also positioned our sun in the corner of the Milky Way, which in his theory was the entire universe. Oddly, Curtis counter-argued that the sun was rather near to the center of our galaxy.
Wrong.
Both of these gentlemen were right and wrong. Curtis got the size of the universe somewhat right, but he failed to accurately calculate the sun's position in our galaxy. Shapley was obviously wrong about the size of the universe. However, he was quite accurate in positioning the sun. We have come a long way since then. We understand the observable universe better, and in 1996, the debate was resurrected once more. And this time it was galaxy researchers Sidney Vandenberg and Gustav Tammann who argued over this question. Gustav Tammann firmly claimed that the Hubble constant has a low value of about 55 kilometers per second per parsec, but Vandenberg offered evidence supporting a higher value of the Hubble constant, 80 kilometers per second per parsec.
I hope you are going to explain what the hell you're talking about right now, because all I'm hearing is he did the Kessel run in less than 12 parsecs.
Signifying that the universe may be younger and smaller than we had thought before. Hubble constant, for the uninitiated, is the unit of measurement used to describe the expansion of the universe. The cosmos has been getting bigger since the Big Bang kick-started the universe, and it in fact is getting faster in its acceleration as it gets bigger. However, Tammann did have some strong arguments. Both of them had data supporting their side, and neither succeeded in convincing astronomers from the other camp. Even today, 25 years after that debate, astronomers are limited by both assumptions and a lack of adequate data to agree on the cosmic distance scale. Yet, based on the available data, astronomers can set some limits on what must be true about the size of the universe. Thanks to the powerful telescopes available in present times, astronomers can observe galaxies located over 13 billion light-years from Earth. Our current cosmic horizon of visibility is somewhere around 26 billion light-years in diameter. But it is inarguably true that the universe should be much larger than what we are able to see for now. If the hypothesis proposed by Alan Guth in 1980 is true, then the universe must have expanded so rapidly in its earliest moments that it ballooned from the size of a subatomic particle to the size of a softball almost instantly. If inflation did indeed occur, then the universe is much larger than we might expect based on current observations. And that's where it gets wonky, for lack of a better term. In our video about Was the Big Bang a White Hole? Link in the description below. We explained how the Big Bang didn't occur at one single point, but everywhere.
I am not mature enough for you to say was the Big Bang a white hole. Not mature enough at all. Nope.
So keeping that in mind, if inflation happened in the earliest moments of time and space, then it should have occurred in many places, and perhaps many here means in an infinite number of places. It's a pretty valid school of thought that many of those places where inflation helped expand the universe may lie beyond our cosmic horizon and the limits of the space-time continuum we are so familiar with. So in that case, either our universe is indeed infinite, or maybe there is another universe beyond our limitation.
Then the question is that if you exist in this universe and there's another universe next to this universe, one, do they have the same properties? And would there be a way to travel from this universe to that universe? And if you made the trip to that universe, would you be able to exist in that universe depending on whether or not the properties are the same? Or is matter transferable because we're made of matter? That's the only smart thing I'm going to say for the rest of December.
Andromeda, the nearest galaxy to the Milky Way, is somewhere around 2.5 million light-years away from us. When we try to see what's going on in there, we are actually looking at what it must have looked like about 2.5 million years ago. We have no idea what Andromeda Galaxy looks like today, because the light cannot get any sooner from that galaxy than our own. Light needs 2.5 million years to reach our eyes from the moment it was emitted. As we look to greater distances, we
from Andromeda
also wind up looking back in time. More distant galaxies appear as they were tens of millions, hundreds of millions, or even billions of years ago. As we look even farther away in space, the light we see from the universe comes from its progressively younger days. And when we kept on seeking answers to whatever light has offered us to see, we found the light emitted all the way back in the beginning, the cosmic microwave background. CMB, or cosmic microwave background, is the leftover glow that was emitted by the Big Bang. We also discovered that, except for a few regions being more or less dense, the universe was perfectly uniform. These non-uniform regions constituted only 1 in 30,000ths of the universe. But for a universe as vast as it is, this much area was enough to give birth to stars, galaxies, galaxy clusters, and cosmic voids we see today. And astonishingly, the space curvature is perfectly flat. If that wasn't the case,
it also gave birth to Hennessy and some good weed.
Distant lights would converge or diverge. But light always moves in its original direction with the fluctuations we have, and thus indicating perfect flatness. The conclusion we get from this combined information is that if the universe was finite, it has to be at least 250 times bigger than what we call the observable universe. The calculation reasoning behind that is that as we live in a three-dimensional universe, 250 times the radius means 250 to the third power times the volume, or more than 15 million times as much space. That would be about 11 trillion light years in all directions. But big as that is, it still isn't infinite. Now let's consider if the universe does have an edge. What's beyond that? There's a reason to believe that the universe may not have an edge at all. For now, we are certain that the Big Bang indeed began the observable universe as we know it. But what if time and space existed long before that? We are aware that long before the Big Bang, the universe was filled with only—
Well, the way that it was explained to me is that if you exist on, like, let's say you take a basketball and you live on the surface of a basketball, it doesn't have an edge, like the Earth doesn't have an edge because it's spherical. And I've heard that that's the same thing that applies to the universe.
Only energy inherent to space itself. It was also expanding at a constant exponential rate, what we call cosmic inflation. This also created new space so quickly that the smallest physical length scale, the Planck length, would be stretched to the size of the presently observable universe every 10 to the negative 32 seconds. It's true that inflation came to an end in our region of space, but we still need an answer to 3 questions. Number 1, how big was the region of the universe post-inflation that created our hot Big Bang? Number 2, is the idea of eternal inflation correct? Number 3. And finally, how long did inflation go on prior to its end and the resultant hot Big Bang? These questions are so broad that explaining the answers to these questions would require a whole video of its own. From our best observations, we know that the universe is an awful lot bigger than the part we can observe. Beyond what we can see, we strongly suspect that there's plenty more universe out there just like ours, with the same laws of physics, the same types of physical cosmic structures, and the same chances at complex life. However, a single universe or multiple universes, or if you'd like to call it a multiverse, whatever we might find at the end shouldn't be infinite.
Yeah, that Doctor Strange
Unless inflation
movie,
went
bro.
on for a truly
Multiverse of
infinite
Madness
amount of
is
time,
garbage.
or the universe
First one
was
was
born
way better.
infinitely large. The universe ought to be finite in extent. But to get the correct answer, we may have to find a way to extend our reach beyond the observable universe, for the answer might be encoded somewhere else in the universe itself. Until then, the possibilities are infinity
and beyond. I think the universe is infinite, man. Just because it's like we can't see beyond what we can see beyond, and beyond that is the beyond. Mic drop. I'm gonna leave it there. Let me know what y'all thought about the video, man. My name is Rain. Catch you on the flip side. RCP, so wait for it.